We want to find the limit as x approaches 5 of x squared minus 3x minus 10 divided by x minus 5. Now, normally, you could use one of the limit laws. So we have a limit law that says the limit as x approaches a of f of x divided by g of x is just the limit as x approaches a of f of x divided by the limit as x approaches a of g of x. So in other words, we could take the limit of the numerator separately and the limit of the denominator separately and then just divide them. But we have a problem here. Our g of x here is x minus 5. And what is that limit? So if we did the limit as x approaches 5 of x minus 5, we end up getting 0, and that's not so good in the denominator. So turns out we can't use this limit law here. We have to do something else. But that's okay, because x squared minus 3x minus 10 factors. So I can factor this. I need two numbers that add to negative 3 and multiply to give negative 10. And I think 2 and negative 5 will work, so this would factor as x plus 2 times x minus 5. Now let's just check that. 2 plus negative 5 is negative 3. 2 times negative 5 is negative 10. Yeah, that works. So now I can say that my limit as x approaches 5 of this thing here, x squared minus 3x minus 10 over x minus 5, is the same thing as x plus 2 over x minus 5 divided by x minus 5. And now I can cancel this. Gone, and I just have the limit as x approaches 5 of x plus 2. And you should keep writing the limit out front up until the point where you actually take the limit. And that's what I'm going to do right now. So this limit's very easy. I can just plug in the 5 here, and I get 5 plus 2, and that's 7. Okay, so that was pretty easy. One thing I should point out, this quantity here, x plus 2, x minus 5, divided by x minus 5, well, that doesn't equal x plus 2. I mean, it almost equals x plus 2. It equals x plus 2 everywhere except for the point where x is 5. Because when x is 5 over here, we have a problem. We're dividing by 0. And when x is 5 over here, we don't have a problem. It's just 5 plus 2 is 7. When you're taking a limit, though, you have no problem saying that the limit of x plus 2 times x minus 5 over x minus 5 equals the limit of x plus 2, because the limit doesn't care what happens at 5. It only cares about what happens as you get close to 5. So there's no problem there. To really see this, let's look at a graph. So here's a graph of the function x squared minus 3x minus 10 over x minus 5. That's the same thing that we had before. And you see it looks like a line, except there's a hole right here. Well, that's because of the x minus 5 in the denominator. And we saw that the limit as x approached 5 ended up being 7. Well, that makes sense. As we travel along the graph and get closer and closer to 5 on the x-axis, we get closer and closer to 7 on the y-axis. But the limit doesn't care what happens right at x equals 5. It only cares about what happens as you get close to it.